we're looking at this problem, which is similar triangles, triangle FED, which is similar to ZYX. We're going to find an unknown value here. So we're looking for the value of X, and we can see it is embedded here in some of these expressions that represent some of the side lengths. So we have the triangles are similar, so we can set up proportions. Now, a couple different ways to do this. You can go based on sort of the side length, and sometimes that works. It's never a great plan, though, to go on just what we think we see. We kind of have to do that sometimes if they don't give us a similarity statement. Like EF is the smallest side, so is ZY. But really, the better way to do that is to look at the letter orders. So if I see that FE are the first two letters, then that definitely corresponds to ZY. The similarity statement always supersedes, means it's more important that it comes first than based on what we think we see with size. But this, it looks like they drew it somewhat to scale. Okay, so ED would be this side right here, and that's the second two letters, so that would definitely correspond to YZ. So what I'm doing right here is just sort of trying to color code it a little bit, so that's the YZ. And that is actually the medium length side on both of them. And then I got DF, which are my first and last letters. So I'll do that here in purple. And that's going to correspond to ZY, or ZX, excuse me, ZX here. And this is sort of a handy technique to sort of color code the corresponding sides. And you can do that again with the letter order from the similarity statement. And then I can see how kind of everything fits together. Now I want to solve for X. So I have really two different options. I can use the pairing from the green that has an X. I can use the pairing from the purple. And then I can just use the pairing from the blue as sort of an easy proportion to set up. So I'm going to go ahead and do it up. It says work over here, but I'm going to write it right here so we can kind of keep it all on the screen. I'm going to use that 8:4 to start it off because the blue corresponding sides, that's going to be a nice thing for me, I think, to work with. And I'm just going to do the green pairing because I think that's fairly straightforward. I went from the big triangle to the small. So as I set up my second proportion, I want to do the same thing. I'm definitely going to start over here with 10. 10 corresponds to X minus 1. And then from here, I can just do cross products. Now, there are multiple correct proportions that we could have set up here. And I'll probably do another one here with the purple just to show that it all fits. So we end up with 40. This is going to be 8 times all of that. So that's 8 times X minus 1. That's going to be 8X minus 8. So I'll add 8 to both sides. And I'm going to get 48 equals 8X, divide by 8, divide by 8, and X is equal to 6, right? 6 is equal to X is equal to 6. Now, especially since here I have the X in multiple locations, I kind of want to just sort of check my work and make sure that this does work. 8 is double 4, which means if I plug in 6 here, 10 should be double that number. And it does look like it's going to work. 6 minus 1 is 5, right? So this would be 5. 10 is double 5. It's following that same relationship. And then if I do it here with the purple, if I plug in my 6, and this I'm probably going to do on the calculator. Oh, I don't really need to, but I'm going to anyway. 3. Okay, so it's going to be 6 minus 1. Oops. Okay, let's see what I'm writing right there. I'm just typing my X equals 6 into this expression here. That's giving me 15. 15 corresponds to the 7.5, and 7.5 doubled is 15, right? If this is 15, it does work that it is doubled. Okay, so X equals 6 is fine. And if I was just doing this kind of on my own, I'd be done. But I thought I would just sort of show you that you can set up a different proportion. Like I could use these purples, 3 times X minus 1. That corresponds to 7.5 in the same way that 8 corresponds to 4. And then I'm going to have to do my cross products here. This is going to be 4 times 3 times X minus 1 equals 8 times 7.5. 8 times 7.5, 60. And this is going to be 12 times X minus 1. I'm going to distribute that 12. 12X minus 12 is equal to 60. I'm going to add 12 to both sides. And I'll get 12X equals 72. Dividing by 12, I'm going to get the same answer I did before, X equals 6. And part of the reason that I bring this up is, one, to check my work, to make sure I got the same answer both times, which I did, right? X equals 6, X equals 6, X equals 6, here it is. But the other thing that is kind of nice to point out is if you look at this, this is clearly a more complicated proportion than what I did here. And you can be kind of strategic when you're deciding how to set up your proportions to pick the easier setups. And I can even make my life even more complicated if I had done the purples as one pair and the greens as another pair. Look here, it'll be even more complicated. 3 times x minus 1 compares to 7.5. Right, that's from the purple relationships, in the same way that 10 corresponds to x minus 1. And this would work, but this is going to get significantly more challenging because I'm going to end up with a quadratic. I'm going to end up doing an x times an x, which is going to give me an x squared. It's going to give me a whole second answer, which is going to end up being superfluous. So it's not that you can't do it that way, but you're just making your life more challenging. I would definitely kind of strategically look through and peek at the different proportions that you could set up and pick the one that is going to be the easiest to follow through on algebraically, which would be this guy. Okay, hope that's helpful. Message me anytime with questions.